This lesson is called the building blocks of geometry. And the reason it's called that is because in this lesson we set the foundation for the entire year. And where we're going to start with is the most basic elements of all of geometry for the rest of the year. I need to point out that we are studying this year Euclidean geometry, and that's the geometry of Euclid. You'll hear much more about him throughout the year. All right, so back to the most basic elements. The most basic elements, you might be able to guess this. Number one is a point. A point which is infinitely small with actually no size at all. It has a location in space. Notice I am not telling you a definition of a point. I'm just kind of describing what a point is. All right. Number two, the line. And a line is a straight, continuous arrangement of infinitely many points. And then the third undefined term is called a plane. And then a plane has infinite length and width, but no thickness. Now that we have our undefined terms, we're going to set some standards of how we refer to those undefined terms. We need some symbols, some language, and such to write down what we're thinking about. So let's start off with a point, and we'll start off with point A. Okay, I put it in parentheses. That's the name of it. As I speak, I'm speaking of point A. Well, a point is nothing more than I put a dot there, and if I want to label it, I am going to label it with an uppercase letter. Okay, uppercase. Uppercase is, and it's uppercase block letter at that too. Uppercase block letters for, I should add, I'll add block, okay, if that what's called. And if I add other points, I'm going to continue on. We can do things with subscript. I can make a subscript 2, which is different than that. So I can put points everywhere, all kinds of different names, but I'd like to keep them, and we all would like to keep them, uppercase block letters. All right? Now, if I arrange infinitely many points in a straight continuous arrangement I will make a line. So let's call this line BD. Okay, the English is line BD. The symbol for it is going to look like BD, and we're going to put a line over the top of it with 2 arrows. That means line BD. And then the picture for it, well, there's point B. There's only one point B. And then there's the point D. And then a line will go through those 2 points forever and ever. Such as that. So, English symbol, line. There's other ways, though, we can call lines. You will see, and so that names the 2 points that it goes through. We can also do things with cursive L's, and that refers to a line. And so that would be called line L1. And I guess I don't have to put it cursive there. And so we can get line L1, and I can make another line here. Now, if I do this, then I'm not telling you the points that are on the lines. If I do this, I'm telling you that B and D are both on the lines. Okay? If I put a dot there, let's not call that point E. Point E lies on L1 and L2. F, G. All 3 points that I've just, E, F, and G, lie on L1. It is said then I can say that E, F, and G are collinear, meaning they lie on the same line. Collinear. Lots of vocabulary coming at you today. All right, now I'm going to take a bunch of lines and put them together, going in infinite direction in all the different ways. And of course, I'm going to make the third undefined term, and that's called a plane. So, of course, we have a name. So if I call it plane, what letter should I say? We'll just do plane Q. That's the English. Here's the weird thing. For planes, we make a picture that kind of looks like, well, it goes on this way forever, it goes on this way forever, it goes on this way forever, and this way forever. But it's flat, not bending, flat, but goes on forever and ever like this way. So the picture is like this. Oftentimes, you don't see 4 lines, you just see the middle part. And to write a symbol for it, they use the cursive uppercase. So lowercase for lines, cursive uppercase, and I think that this is a Q. I should have chosen. I don't know. Is it? That's terrible. I think it's a Q like this. I'd be okay with you if you tried to make it fancy like that. I won't be too hard on you for your script letters on your planes. The next vocabulary term is called line segment, and of course it consists of 2 points called endpoints and all the collinear points between the endpoints. Collinear meaning on the same line. So we have 2 points, 1, 2. I should say that's E and F. There's a line that goes through that, but if I want a line segment, I would follow the line that goes through there. It goes on forever, but I'm only talking about the points between the endpoints. So that's a picture of EF. The symbol for EF, line segment EF, is the same as a line, except for this time we have no arrows. So there's the symbol, and of course English we call that line EF. Fantastic. If I put EF and I put a 5 centimeters, now I'm telling you that EF has the measurement of 5 centimeters. And to say the measurement of 5 centimeters, what I'm going to do is put an M before the EF. And of course that means measure. So the measure of line segment EF, oh, I put line up here, line segment. The measure of line segment EF is equal to 5 centimeters. That brings me to an interesting point. You've seen these symbols before. The first one I just used. That means equal. Well, now what does equal mean? I like thinking of equal as the same measure, or you could say the same size. This symbol with 1, it looks like a tilde, that is for similar. Similar. And that, it means same shape. 2 is an approximation or approximate. So that's used for when we're rounding. We're not saying it's equal. It's probably, we could talk about it, and it's usually a rounding of a measure, right? or size. We can use still. Sometimes people talk about an approximate shape. Then this symbol is an equal and similar together. Same measure, same shape. And that's, I put the two together, and that is congruent. And of course, that means same shape and the same size. Four different symbols meaning four different things. All right. So when I say EF is congruent to AB, I'm telling you something. I'm telling you that they have the same shape and the same size, right? These are line segments. Now, you can imagine, how in the world could I say something like PQ is congruent to AB? How can a line be congruent to a segment? This makes no sense at all. So, since it makes no sense, we're not going to do that. In fact, two segments, line segments, are congruent if and only if they have the same measure. So the only way that I get two segments to be congruent is if they have the same measure. And there's a couple ways of showing that. What did I write? I wrote EF is congruent to AB. This is saying congruent. I told you that two segments are congruent. Different way, the same measure is written differently. If I want to say they have the same measure, that's when I write down the M, the measure of EF and the measure of segment AB. Then I'm talking about how far it is from point E to point F and point A to B. These are talking shape and size together. This is only talking about how big they are. And the thing is, they're congruent is because line segments only come in one shape. So if these two segments are the same measure, then they are congruent. Now, the symbol that goes in between this is not a congruency, because measures cannot be congruent. Measures are numbers. Measures are values. Measures can be equal. That's one of my pet peeves. Equal and congruent are not interchangeable. Don't do it. All right? Measures are for numbers, and congruencies are for shapes and numbers put together. Okay? There's one other way of saying this. If I write EF and AB with nothing above them, and as you remember, the capital letters are reserved for points. So this is EF. What that translates is the distance from point E to point F. And this likewise translates to the distance from point A to point B. So this is saying the same thing, but in a different way. This says that the distance from E to F is the same distance as A to B. These are all symbolically. Now, if I'm going to mark them, let's here we'll make this EF, and I'll make this one AB. There's a couple ways I can mark them. I can put tick marks on them, and if the tick marks match, then I'm telling you that those segments are the same measure. I can also put just a number. I could put the value like I did earlier. I could say that is 8 centimeters. If I put that's 8 centimeters and I put this one's 8 centimeters, well, magically 8 centimeters didn't shrink, and that's how you do it. If I have a segment, let's see, I'll make a polygon with a bunch of segments. If I put this tick here and that tick there, that means those two are congruent. I could also put 2 ticks, meaning these two are congruent. And if I put nothing there, then it's congruent to nothing. If I put a 5 here, that doesn't tell me, it tells me how far it is from here to here, but doesn't tell me how it relates to the other ones. Now we're going to introduce angle. Angle is, the definition is 2 rays with a common endpoint, which means that they share one point. So I have a ray that goes this way, and that's ray AB. I have another ray that goes this way, and that's AC. These share an endpoint of A, and they make an angle. And this would be known as angle A. That's one way of writing it. We could also call this using the points. This would be angle, and we name it with the common endpoint in the middle. So this was angle BAC or angle CAB. Now I can say angle A because there's nothing else. There's no confusion about that, and that is the angle. And there we go. Symbolically, this we put angle A, so it's a little, looks like that angle right there. Or we can do angle BAC, or we can write this as angle CAB. All of those three are acceptable for that picture. If we're going to measure these angles, we measure these angles in degrees. Okay? Measured in degrees. And I'll put a note, always the short way. And what I mean by that is if I'm measuring angle BAC, I'm measuring right there. Because we will talk about it, but there are different names for going around the long way. So the measure of all them, I should write that, the measure of angle A, or which is going to be also the same thing as the measure of angle BAC, M being the measure, and those two are numbers, so those two must be equal. We're talking about the same thing. Not congruent, equal. Lastly, for this is the word bisector. And bisector means that we cut it into 2 equal halves. And I can make a bisector of a segment. I can make a point can be a bisector. A line can be a bisector. How about this? We'll make line 1 a bisector. Line 1 is a bisector of segment EF. Now, I said it, but I've actually not marked it on my picture yet. The picture should have the same as what I want to say in English. So here I got L1. Well, if it cuts it into 2 equal halves, I need to mark it such. So I have to mark those two as congruent. And there are a couple ways that you might remember. I could put tick marks, or I could put numbers. I could also name that point, and I could go and write EA distance is equal to AF distance. That also. You can also bisect an angle as long as it's marked. Here's line 2, and here's angle J. Now it's not marked yet, so I'm going to mark it by putting a little arc over here and mark the two halves as being equal. And the same rules apply. One tick, or I could match it. So if I put 2 ticks and match it over here, I could put 2 ticks over there. All right. I think we have done plenty for today, and I will see you tomorrow, and we will explore this even more.